In January 2000, the board of a company headquartered in Bracknell agreed to a sale. The buyer was Thomson CSF, a massive French defense conglomerate. The price was £1.3 billion. Within a brutally short span of time, the British name on the factory gates was removed, replaced by a new global corporate identity. The manufacturing legacy was rebadged. The name that had defined British military and signals intelligence listening for exactly half a century simply ceased to trade on the London Stock Exchange. A decade earlier, that same name had meant precisely the opposite. It was not a target for acquisition. It was the undisputed heavyweight of British electronics. It was the company that built the communications architecture of the British Army. It was the engineering powerhouse that had looked at the highly speculative concept of civilian cellular telephones, applied military tactical radio logic to it, and birthed Vodafone. But the real story of Racal in Britain is not the story of a corporate buyout. It is the story of a company that mastered the absolute precision of analog reception, only to be destroyed by the very digital mobile future it helped create. Every week, we tell the stories of British radios, wireless makers, and listening habits that once shaped how people heard voices, music, and memory, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place. In London, in 1950. In 1950, Raymond Brown and George Calderhead sat in a modest office in London and formed a consultancy with a total working capital of just £50, a sum roughly equivalent to £1,700 today. They took the Rye from Raymond and the Cal from Calderhead and registered Racal Limited. They were not aiming to build wooden-cased table radios or radiograms to sit gracefully in the British sitting room. They were ex-military men, deeply embedded in the uncompromising logic of defense contracting, logistics, and serious communication. They understood a fundamental division in British broadcasting. While the British public wanted to listen to the light program, the British state needed to listen to the world. The early years of the Cold War presented a specific, terrifying reception problem for the Ministry of Defense. The world was rapidly dividing into hostile blocs, and the invisible architecture of this new conflict was built on radio waves. Signals intelligence, diplomatic communication, and naval coordination relied heavily on the high-frequency bands, what the public casually called shortwave. A broadcast band that can carry signals over long distances, often bouncing off the ionosphere to cross countries and continents. But listening to shortwave with extreme military-grade precision was physically difficult. The British military and intelligence services, particularly the Royal Navy and GCHQ at Cheltenham, were relying on aging World War II-era receivers. These wartime sets were physically robust, heavily built to survive combat, but they suffered from a fundamental, inescapable flaw of analog electronics. They drifted. When a receiver was tuned to a specific faint frequency in order to monitor a Soviet transmission, a distant submarine, or a diplomatic wire, the immense heat from the internal components would cause the electronics to physically expand. Valve, a glass electronic device used to control and amplify signals before transistors replaced it. As the 20 or more valves inside the heavy cabinet warmed up, changing the temperature of the chassis, the tuning would slowly, inevitably slide away from the station. A radio operator could not simply tune the set and walk away. They had to sit with their hand resting constantly on the tuning dial. Tuning dial, the scale or display that shows which station or frequency the radio is tuned to. The operator spent hours chasing the signal up and down the band, micro-adjusting the frequency to keep the human voice or the rapid chatter of Morse code from slipping permanently into static. For a civilian trying to find a weekend music broadcast, drift was a nuisance. For the Royal Navy, drifting receivers meant lost orders. For GCHQ, drifting receivers meant lost intelligence. The British absence was entirely clear. The state desperately lacked a communications receiver that could be tuned to an exact kilohertz, left entirely alone for 12 hours, and still be perfectly locked onto that exact frequency when the operator returned. They needed a rock-solid electronic anchor. They needed stability that defied physics. The breakthrough did not come from a massive corporate laboratory in London. It came from a South African engineer named Dr. Trevor Wadley. Wadley had invented a circuit topology, a complex, mathematically beautiful arrangement of valves, mixers, and oscillators that fundamentally canceled out the thermal drift of the radio. If the internal oscillator drifted due to heat, the Wadley loop instantly inverted that error and fed it back into the circuit, essentially erasing the mistake in real time. It allowed a high-frequency radio to be tuned with absolute, unshakable stability. It was an engineering marvel. Wadley brought his patent to Britain and offered it to the established giants of the British radio industry. Marconi, the historic titan of Chelmsford, reviewed the designs. They found the circuit too complex, too demanding to manufacture at industrial scale, and entirely too unconventional for their established production lines. They passed on the opportunity. Brown and Calderhead at Racal, operating out of a modest, cramped factory space in Isleworth, Middlesex, did not. They looked at the Wadley loop and saw exactly what the Royal Navy was begging for. In 1954, Racal secured the exclusive rights to manufacture a receiver based on Wadley's principles. Available reports indicate they gambled the entire financial existence of their young company on developing this single prototype. They poured every available resource into making Wadley's complex mathematics work inside a physical metal box. In 1955, the prototype was officially demonstrated to the Royal Navy. The results were immediate and startling. It did not drift. It did not wander. It held the frequency with a rigid mechanical stubbornness that the military had never experienced before. The Royal Navy immediately placed an order for 300 units. The unit price was substantial, around £300 per receiver, the equivalent of over £7,000 today, reflecting a level of engineering far beyond any domestic wireless set. This single order transformed the company overnight. Racal urgently moved their operations from Isleworth to a much larger, modern facility in Bracknell, Berkshire, simply to meet the sudden, overwhelming demand. They called this new, heavy-duty receiver the RA-17. The British listening market for the RA-17 was never the high street. It was the windowless rooms of listening stations, the communications decks of warships, the BBC monitoring service at Caversham, and the intelligence outposts of the shrinking British Empire. The RA-17 was a machine purpose-built for the Cold War, born in Isleworth, built in Bracknell, and deployed wherever the state needed to hear a whisper in the dark. To understand the Racal RA-17 is to understand a piece of heavy British industrial architecture. It was not a radio you carried. It was a radio you installed. If a British family in 1955 bought a domestic wireless set for their sitting room, they bought a wooden cabinet that blended politely with the furniture. The RA-17, by contrast, was designed to survive the end of the world. It weighed nearly 32 kilograms, over 70 pounds. It was housed in a massive, uncompromising die-cast aluminium chassis designed to shield the delicate internal circuits from both electrical chaos and physical trauma. The front panel was a thick expanse of gray or olive-drab metal. It was dominated by heavy, knurled knobs that clicked into place with the decisive, heavy mechanical authority of a rifle bolt. Operating the RA-17 was a distinct physical discipline. A civilian turning on a high-street radio would simply flip a switch and turn a string-driven pointer along a printed glass dial. The military operator of an RA-17 first selected the megahertz band using a large, heavy selector switch that clunked solidly into its detent. Then, they approached the main tuning mechanism. This mechanism was completely unlike a domestic set. Tuning dial, the scale or display that shows which station or frequency the radio is tuned to. The RA-17 used an extraordinary mechanical and optical system called a film scale. It was a long strip of photographic film, approximately 1.5 meters in total length, passing smoothly behind a glass window. It was illuminated from behind by a glowing dial lamp. As the operator turned the main tuning knob, the film moved steadily across the window, allowing the frequency to be read down to a single kilohertz. This gave the receiver an unparalleled level of visual precision. Inside the chassis, 23 glass valves glowed brightly, generating an immense amount of heat. Valve, a glass electronic device used to control and amplify signals before transistors replaced it. In a standard radio, tuning relies heavily on a simple mechanical component, tuning capacitor, a component that changes the circuit's tuning so the radio can select one station from many. But standard tuning capacitors physically expand and shift their electrical values as they heat up, causing the station to drift away. The Wadley loop architecture inside the RA-17 bypassed this vulnerability entirely. It possessed a stability that felt like magic to a generation of radio operators raised on drifting, unreliable wartime equipment. It also possessed extraordinary sensitivity. Sensitivity, how well a radio picks up weak signals. It could pull a faint, whispering Morse code transmission from a distant Soviet trawler out of the static. Once found, it relied on its exceptional selectivity. Selectivity! How well a radio separates one station from nearby stations. Even if two transmitters were operating on nearly identical frequencies, the RA-17 could carve one away, dropping it into silence, and deliver the other with absolute clarity. The sound did not come from a built-in speaker hidden behind a decorative cloth. The audio was delivered through an external loudspeaker, or, more often, straight into heavy military headphones. Loudspeaker, the part of a radio that turns the electrical signal into sound moving through air. The audio was raw, isolated, and absolute. It cut through atmospheric noise and electrical interference. Interference, unwanted noise or disturbance added to the signal. The British distribution breakthrough for the RA-17 was entirely institutional. You could not walk down the high street and look at an RA-17 in the window of a local radio dealer. You could not sign a weekly rental agreement for one at Radio Rentals. At a time when a highly respected Bush or Murphy table radio might cost 15 to 20 pounds, the basic RA-17 cost roughly 300 pounds. With specialized adapters, low-frequency converters, and mounting racks, the price easily reached the equivalent of a small family car. The British radio moat that protected Racal was not branding, and it was not clever marketing. It was pure, unadulterated performance under extreme duress. The military could not afford to miss a transmission from a submarine because a component had warmed up. Racal guaranteed that the message would be heard, regardless of the temperature in the room. The British state endorsed it by tearing out their old equipment and standardizing entirely on Bracknell's engineering. It was purchased in massive quantities by the Ministry of Defense. GCHQ installed vast floor-to-ceiling racks of them in their highly classified listening posts. The BBC monitoring service at Caversham relied on them heavily to hear foreign broadcasts across the Iron Curtain. Reuters used them to receive continuous, vital global news feeds. Wherever a British institution needed an absolute guarantee of reception, an RA-17 was bolted to the desk. The early British market metrics were unprecedented for a piece of specialist military hardware. Racal ultimately manufactured and sold over 30,000 of these massive receivers. It broke beyond Britain and became the standard high-frequency receiver for NATO forces. It sat in listening posts in Cyprus, in communications relays in West Germany, and in Royal Navy ships plunging through the grey swells of the North Atlantic. For a British radio operator of the era, sitting down in front of that heavy metal panel, feeling the heat rising steadily through the top grille, and turning that incredibly smooth film scale, was the ultimate expression of control over the airwaves. Grille, the opening or fabric-covered area through which sound leaves the radio cabinet. Every dial, every room, every voice. The badge on the dial was not decoration. It was a promise about reception. By the late 1960s and early 1970s, Racal had fundamentally outgrown the RA-17, just as British electronics had definitively outgrown the glowing glass valve. The company had transformed Bracknell from a single, busy factory into a sprawling, interconnected complex of defense electronics. They had expanded far beyond the isolated act of listening. They were now building the networks that allowed the British military to speak. The British listening ecosystem that made Racal an industrial giant was not based on the high street. It was an entirely institutional loop. Bracknell built the circuitry. The Ministry of Defense wrote the checks. Mullard supplied the specialized components from their British factories. GCHQ analyzed the intercepted signals in Cheltenham. The Royal Navy installed the heavy mounting racks in their fleet. The BBC monitoring service at Caversham transcribed the foreign broadcasts. The British Army carried the tactical sets across West Germany. The Cold War provided the relentless, unforgiving demand. The defining British cultural moment for Racal was not a famous consumer product placed proudly on a sitting room sideboard. It was a military radio system that became the physical backdrop for an entire generation of British service personnel. In the late 1960s, the British Army recognized that its communications infrastructure was dangerously fragmented. They were using a chaotic mixture of older, incompatible radios. They desperately needed a unified, modern family of combat net radios that could talk to each other seamlessly. They needed sets that could be carried on the backs of infantrymen in the freezing rain, bolted firmly into the steel turrets of chieftain tanks, and installed in the back of bouncing Land Rovers. The equipment had to survive mud, physical impact, deliberate electronic jamming, and the sheer mechanical abuse of the battlefield. This vast, ambitious procurement project was called Klansman. Racal became a primary contractor for the system, working alongside other British heavyweights like Plessy and Mullard. To achieve the portability the military demanded, Racal had to abandon the heavy valves of the RA-17. They moved entirely to solid-state architecture. Transistor, a small electronic component that controls or amplifies signals with less heat and power than a valve. Using transistors allowed the new radios to run on battery power for extended patrols, generating virtually no heat and surviving drops that would have shattered glass components instantly. Racal manufactured several key pieces of the Klansman puzzle, including the PRC-349, a small, highly ruggedized tactical radio used at the infantry section level. VHF-FM, a radio band that gives clearer sound over shorter distances than older AM bands. They also built the massive UK VRQ-301 sets for vehicle mounting. Klansmen defined the physical, sensory experience of soldiering in Britain for 30 years. If you served in the British Armed Forces from the late 1970s, through to the early 2000s, you knew the exact smell of the green canvas carrying harnesses. You knew the heavy, satisfying click of the channel selector dial turning under a gloved hand. You knew the precise, mechanical resistance of the press-to-talk switch on the handset. You knew the dead weight of the battery blocks pulling at your shoulders. You knew the distinctive matte olive green paint of the cast metal chassis. Racal was no longer just a company that made listening devices. It was an empire of secure, encrypted communications. It had become the nervous system of the British Armed Forces. But their ambitions in Bracknell were about to expand beyond the military entirely. By the beginning of the 1980s, Racal was operating at a scale that dwarfed traditional British radio manufacturers. Under the intensely aggressive leadership of Sir Ernest Harrison, the company began to swallow its competitors. In 1980, they acquired Decca Radar, expanding their reach deep into marine navigation and electronic warfare. By the early 1980s, Racal was officially Britain's third-largest defense contractor. The Bracknell facilities alone employed thousands of skilled workers, engineers, and assembly technicians. They were exporting their advanced tactical radios, the highly successful Jaguar and Panther lines, to armed forces across the globe. At its peak, Racal was untouchable. It was highly profitable, politically connected, and technically supreme. But the most significant milestone in Racal's history, and arguably in the history of modern British telecommunications, was an audacious application of military logic to civilian life. In 1982, the British government announced it would open up licenses for a radically new technology: civilian cellular telephone networks. It was an entirely unproven market. Most established high-street electrical retailers, traditional telephone providers, and consumer electronics companies viewed mobile phones as absurdly heavy, prohibitively expensive novelties meant only for wealthy executives. They could not see how it would ever become a mass-market habit. Sir Ernest Harrison and the senior engineers at Racal viewed the proposition entirely differently. A cellular telephone network was, fundamentally, just a massive, highly complex, tactical radio net. It required securing multiple radio frequencies, building incredibly reliable base stations, managing seamless handoffs between transmitters as a user moved, and manufacturing rugged portable receivers. Racal knew how to do this better than anyone else in Britain. They had spent 30 years building combat radio networks that did exactly this, maintaining secure links while the users were under heavy artillery fire. Building a similar network for businessmen driving down the M4 motorway seemed, from a purely engineering perspective, relatively simple. Racal formed a joint venture to bid for the cellular license, and they won it. They initially named this new subsidiary Racal Strategic Radio, but they quickly realized that a civilian audience would not buy a product that sounded like a military strike command. They needed a friendlier, consumer-facing brand. They abbreviated the concept of voice and data over phone. They called it Vodafone. On January 1, 1985, the very first Vodafone cellular call was made in the United Kingdom. The early mobile phone handsets were essentially the size and weight of bricks. They cost thousands of pounds, but the network worked flawlessly because its invisible architecture was built directly upon the backbone of Bracknell's decades of tactical radio expertise. For a brief, extraordinary window in the mid-1980s, Racal stood at the absolute summit of British wireless capability. The peak British presence was everywhere, simultaneously. In a highly secure, windowless room in Cheltenham, an intelligence officer was carefully tuning a glowing Racal receiver to intercept a signal. On a bleak, freezing training area on Salisbury Plain, a British infantryman was speaking quietly into the green handset of a Racal Klansman radio. And on a crowded train pulling into London Paddington, A stockbroker was lifting a heavy plastic handset to their ear, connected seamlessly to a cellular network designed, built, and owned by Racal. The name meant absolute reliability, whether it was painted in military green, stamped into a thick aluminium chassis, or printed on a glossy corporate brochure. The factory hummed. The military ordered. The signals traveled. Racal had conquered the airwaves. The decline of Racal as a British radio empire is profoundly different from the collapse of traditional high-street manufacturers. It was not destroyed by Force One, the rising costs of wooden cabinets and domestic labor that crippled the early valve makers. It was not destroyed by Force Four, the flood of cheap, imported Japanese transistor radios that hollowed out the British domestic market in the 1970s. Racal was destroyed by a much more complex structural inevitability. It was dismantled by Force 5, technological, retail, and listening culture shift, compounded by the end of global geopolitical conflict, and the uncontrollable, staggering success of its own civilian spin-off. The British turning point arrived not with an engineering failure on the factory floor, but with a financial paradox in the City of London. By 1988, Vodafone was growing at an explosive, terrifying rate. The civilian desire to carry a telephone in a pocket was proving to be infinitely larger and vastly more profitable than the Ministry of Defense's requirement for heavily armored combat radios. The tail was rapidly outgrowing the dog. The financial markets looked at Racal Electronics plc and saw a severe contradiction. They saw a brilliant, high-growth, distinctly modern cellular telecommunications company trapped inside the heavy, traditional, slow-moving corporate shell of a British defense contractor. The shareholders and institutional investors applied relentless, unforgiving pressure on Sir Ernest Harrison and the board. The City of London demanded that the immense value of the mobile network be unlocked and separated from the volatile, politically dependent world of military procurement. In 1991, Racal finally bowed to the overwhelming pressure of the market. They executed a formal demerger. Vodafone was spun off as an entirely independent, publicly traded company. The retreat of the British military radio empire began the exact day the financial paperwork was signed. The moment Vodafone left the corporate structure, Racal lost its primary engine of extreme financial growth. It was suddenly returned to precisely what it had been before the cellular gamble: a pure defense contractor. But it was a defense contractor suddenly facing a radically, permanently changed world. The geopolitical architecture that had sustained the company for 40 years was collapsing. The Berlin Wall had fallen in 1989. The Soviet Union formally collapsed in 1991. The Cold War, the intense, decades-long geopolitical tension that had justified massive defense budgets and the endless state demand for high-frequency interception, was over. The British Ministry of Defense, like military departments across NATO, immediately began to slash procurement budgets to reap the political benefits of the peace dividend. For Racal, peace meant cancelled orders. The immense, sprawling factories in Bracknell that had spent decades running at full capacity to equip the British Army to fight a land war in Europe suddenly found themselves in a shrinking arena. Racal was no longer competing to build the expansive future of civilian communication. They were now forced to fight fiercely over a rapidly dwindling pool of restricted government contracts. The retreat became physical. The company began to restructure, attempting to adapt to a world that no longer needed tens of thousands of heavy, cast metal listening devices. They began to shrink their footprint. The confident, aggressive expansion that had characterized the 1980s was replaced by defensive consolidation. They had built their entire reputation on permanence, on radios that would survive explosions, extreme heat, and decades of continuous use. But the electronics market no longer valued permanence. It valued rapid iteration. Competitive displacement for Racal did not come from another hardware manufacturer. It came from the brutal, unyielding complexity of software and digital networks. The military radio market was undergoing a violent transition. The British Army desperately needed to replace the aging analog clansman system. Analog, a continuous electrical signal that perfectly mirrors the original sound wave. The military was moving toward deeply complex, encrypted digital architectures. The new British Tactical Communication Project was designated Bowman. It was intended to be a fully secure, digital, voice and data network, integrating every soldier, vehicle and helicopter into a single computing environment. Racal poured massive engineering resources into bidding for the Bowman contract. But the project rapidly evolved into a notorious procurement disaster. Endlessly delayed, massively over budget, and technologically troubled. The Ministry of Defense constantly changed the requirements. The cost of developing the intricate digital waveforms and the highly advanced printed circuit boards necessary for modern, encrypted communications spiraled entirely out of control. Printed circuit board, a board carrying electronic components and copper tracks that connect them. Racal, a company whose DNA was forged in the absolute physical perfection of the Wadley loop and heavy aluminium chassis, struggled to dominate an era defined by software glitches, data protocols, and digital encryption limits. They were hardware masters caught in a software revolution. While Vodafone became a global telecommunications behemoth, buying up mobile networks in Germany, the United States, and across the globe, its former parent company continued to bleed. To maintain cash flow and appease restless shareholders, Racal began to sell off vital parts of its empire. They sold their highly respected data communications division. They sold their radar businesses. They restructured their core operations repeatedly. They laid off highly skilled workers in Bracknell and across their other British sites. The vast, dominant industrial footprint of the Cold War began to shrink into a series of highly specialized but entirely isolated business units. The final British chapter was written not on a battlefield, but in a European boardroom. By the late 1990s, the global defense industry was consolidating at a terrifying pace. Mid-sized British firms could no longer stand alone against colossal American defense giants like Lockheed Martin or the emerging European aerospace conglomerates. The cost of research and development for modern military electronics was simply too high for a standalone British company to bear. In January 2000, the French defense electronics conglomerate Thomson CSF launched a formal takeover bid for Racal Electronics. The board, recognizing that the era of the independent British military electronics empire was over, accepted the offer. For £1.3 billion, the company that had built the RA-17, equipped the British Army for 30 years, and birthed the modern mobile phone network, ceased to exist as an independent entity. Shortly after the acquisition, Thomson CSF undertook a massive global rebranding exercise. They renamed the entire expanded conglomerate Thales. The old corporate identities were systematically erased. The Bracknell headquarters changed hands. The engineering patents transferred to a global portfolio. The military contracts were absorbed into the French conglomerate's massive balance sheet. The name Racal, once stamped deeply into heavy metal and trusted with the nation's most sensitive intelligence secrets, was phased out of the corporate branding entirely. The company was sold. The brand was erased. The defense contracts were absorbed. The Bracknell factories were restructured. The metal chassis was abandoned. The name disappeared entirely. The smartphones answered instead. Today, the vast physical infrastructure of what was once the Racal Empire survives largely under the banner of Thales UK. The engineering legacy continues, deeply embedded in modern British avionics, highly classified naval radar systems, and secure digital networks. But the distinct, uncompromising British identity of Racal is permanently gone. It is a corporate subsidiary, not an independent empire. The distinctive olive-green paint is gone. The heavy cast metal chassis is gone. The name that once anchored British intelligence during the Cold War no longer appears on the equipment it helped pioneer. Yet, in the British preservation and enthusiast community, the name Racal holds a status that borders on engineering reverence. On eBay, on vintage radio forums, and at amateur radio rallies in damp village halls across the country, the original RA-17 receivers still command intense respect. The men and women who buy them are not casually interested in domestic nostalgia. They do not collect them because they look beautiful on a sitting room sideboard. They buy them because they are immortal. Restoring a Racal RA-17 is universally considered a rite of passage for a serious vintage radio engineer. These sets require immense physical space, heavy-duty reinforced workbenches capable of holding 32 kilograms of solid metal, and a deep intuitive understanding of valve theory. Enthusiasts spend months carefully sourcing original replacement capacitors from specialist suppliers. Capacitor, a component that stores and releases electrical energy in a circuit. They meticulously clean the complex, heavy mechanical gearing of the film scale. They patiently, painstakingly realign the intricate mathematics of the Wadley loop, using modern oscilloscopes to verify what British engineers achieved with slide rules in the 1950s. This preservation culture extends to the tactical radios as well. Thousands of decommissioned Klansman sets eventually flooded the British surplus market. Today, vintage military vehicle enthusiasts still bolt original Racal PRC-349s and VRQ-301s into the backs of restored Land Rovers, keeping the heavy, clicking hardware alive long after the British Army moved on to digital screens. An old British military radio with a repaired capacitor, a cleaned dial, and a speaker still moving air can do something a modern digital device often cannot: make listening feel attached to a physical place. Not because the heavy metal is old, because the physical act of tuning still asks the listener to meet the signal halfway. The RA-17 demands intention. You do not ask an RA-17 to casually play a generated playlist while you cook in the kitchen. You command it to isolate a single human voice bouncing off the ionosphere from 3,000 miles away, and hold it there in the dark. In Bracknell today, the vast industrial estates that once housed the thumping heart of Racal's manufacturing dominance have been continually, ruthlessly redeveloped. The utilitarian brick buildings and secure testing facilities have given way to modern glass office parks, logistics distribution centers, and newly built flats. The physical site of the Cold War electronics boom is quietly invisible, buried beneath the lightweight architecture of the modern British service economy. There are no blue plaques on the high street for the men who built the Wadley Loop. There are no monuments to the heavy metal that kept GCHQ listening. But there is a surprise footnote to the Racal story, one that completely reframes its legacy in Britain. If you look closely at the structure of the United Kingdom's modern telecommunications infrastructure, if you trace the corporate lineage of Vodafone, one of the most powerful and ubiquitous telecommunications brands on the planet, you trace it directly back to the engineers in Bracknell building green metal boxes for the infantry. The lightweight mobile phone in your pocket, the device that defines modern digital life, is, historically speaking, the direct civilian child of a British combat radio. The network that carries millions of casual text messages was born from the mathematics of artillery coordination. The story of Rockall reveals a brutal truth about how Britain builds, values, and ultimately discards its engineering triumphs. Britain proved it could build the most durable, precise, and trusted communication hardware on Earth. It proved it could engineer a receiver that would hold a frequency through the heat of a geopolitical crisis, and build a tactical radio that would survive the freezing mud of Salisbury Plain. But the market did not ultimately reward permanence, repairability, or heavy physical trust. It rewarded ubiquity, convenience, and invisible digital scale. The empire traded the weight of metal for the speed of data, leaving its formidable history behind to survive only in the hands of the people who still remember how to repair it. Somewhere in a British shed, resting heavily on a reinforced wooden bench, an RA-17 sits, its heavy gray chassis cold, its vast film scale perfectly aligned, waiting for a hand to turn the dial and find one more voice in the air. See you in the next one.